I just wait for the door to close. My name is Chris Scotes. I'm the director here at the Cranbrook Academy of Art and Museum, and I want to thank all of you for coming this afternoon. We open this to the Cranbrook school students too this evening, so I'd be curious to know how many here are from Cranbrook schools. Can you raise your hand? Wow, fantastic. And I hope you guys come back to future exhibitions, programs, events, and lectures. You're always welcome. I think it's great to see you here, and I hope you enjoy this evening's talk, because we are in for a real treat tonight. I'm actually truly honored that as my first official guest here at Cranbrook, I get to welcome John Underkoffler to the podium in a few minutes. And with John's talk, we are clearly going to be pointing towards the future. I've known John since 2008 when he worked with me and a group on the development of something called 5D, the Future of Immersive Design, which was a conference that we did at Cal State Long Beach. We then worked on an exhibition called Tampa, a gestural interface for cinematic design, which really foregrounded John's G-Speak program, which I think he's going to talk a little bit about tonight for sure. But John is the chief scientist and co-founder of Oblong Industries in LA, and he's the developer of G-Speak, the spatial operating environment. And Oblong's technological research is built upon 15 years of foundational work that John did at MIT while he was doing his doctorate, where he was responsible for innovations in real-time computer graphic systems, large-scale visualization techniques, and the I/O bulb and luminous room systems. John saw the I/O bulb as a multi-purpose invention that would allow any architectural space to be used as a surface for the display of visual information. The bulb would record live video on the projection surface, and more importantly, could be implemented in urban planning, where the study of light in and on objects would assist in the organization of structures. But John is well known for his invention of the gestural interface G-Speak. This is an interactive system where data is literally lifted off the screen and is transferred into real space. John developed a stylized version of G-Speak for the 2002 science fiction film Minority Report, which was directed by Steven Spielberg, on which John was the science and technology advisor. I'm sure if many of you have seen that film, you'll remember the iconic scenes of Tom Cruise flipping through video clips of future crimes. These iconic scenes in Minority Report marked a major change in popular thinking about interfaces, which John, I think, is going to talk about tonight, showing how sexy it is to use natural gesture without a keyboard or mouse. Very revolutionary. John has also worked as a science advisor and technology advisor on films including The Hulk, Aeon Flux, Stranger Than Fiction, and Iron Man. And he also serves as the adjunct professor at the School of USC in Cinematic Arts. So really, please help me in welcoming my first official guest to Cranbrook, John Underkoffler, who I really hope you enjoy this evening's talk.
Well, in fact, it's I who am really, really deeply honored to be here at this amazing place. I figure we probably have about 5 minutes together before this august institution realizes its massive mistake and Chris calls security. So let's see how much we can get done together in 5 minutes. I want to talk tonight about technology, but I think that maybe at least one of the vocabulary choices in the talk's title gives you some sense that I come at that idea of technology from a fairly wary perspective, which is perhaps odd because I have to help run a company that is a purveyor of technology. But what I want to talk about tonight is not so much how technology can be applied at a place like Cranbrook or what it can bring to Cranbrook, which is a fairly frequent topic. But rather what technology ought to be able to learn, and ought to be learning, present tense, from places like Cranbrook. And that's a rather less discussed set of ideas, and hopefully we can make our way through some of that here tonight. In particular, I'd like to talk about user interface, that most human piece, or what should be the most human piece of technology, The UI, or the HMI, human-machine interface, is the part that, after all, that's the only piece of the computer we really get access to, right? It's the part that you can see and hear and touch. It's the pixels lighting up. It's whatever you do with a keyboard and a mouse, or whatever other input modality you have, to express your will, to express your intent, and theoretically, at least, control what happens with the machine. So that is the locus of my own work and my own obsession for the last 25 years, probably. And I'll say one more thing before really diving in. It took me a really long time to figure out what, if any, purpose this talk would have, other than showing you a bunch of maybe interesting video clips in what seems probably like a rather meandery drive through some personal history and some technology designs and so forth. But it is this. I would like to try to convince you that what you're going to see that represents about 15 years of work, that hodgepodge of stuff actually represents a coherent and tractable and plausible worldview about how technology and human beings, most importantly, can act together. And I want to do that not so much to convince you that this is the best worldview or a good replacement worldview for what we have now, but rather because if it's possible for us to jointly believe in some sort of mass hallucination that this coherent worldview exists and is an alternative, then that means it's possible for there to be other worldviews, other big picture takes on what technology looks like and who technology is supposed to serve and how it goes about that service. And that really is the goal. If there's room for more than one, then there can be a dialogue. Today, I'm going to posit there essentially is not a dialogue. We're now a technological species. We've made that decision, although it seems more implicitly than explicitly. But who in this room doesn't have one of these leeches stuck to their body? And that's just the beginning, right? That's where we are. We haven't done a lot of decision-making ourselves, all of us sitting in this room, about how that works and what it should look like. But again, if it's possible to imagine an alternative to what we have today, then again, I'm going to suggest that some of us should be at work making that alternative and making sure that we don't get so far down the pike that there is no longer any opportunity for change. So to begin with, I'd like just to sort of engage you in a very simple thought experiment, which is a kind of space-based analogy or framework for considering what it feels like when you use a computer. And by the way, when I say technology, of course, irritatingly, what I mean is computation. I mean computers. We don't call them computers much anymore. We call them smartphones and tablets, but they're all really computers. So that's, for better or worse, and I think worse, what we think of when we think of technology. We think rather less about other equally interesting things, but maybe we can get back to that as well. So when you use a computer, is your mind, is your cognition, is your perception of what's going on kind of a here thing or a there thing? English only has here and there basically to describe close to us and farther away, or maybe very, very far away. Other languages like Japanese have intermediate pronouns and descriptors that are probably useful to think about later. But let's just make it binary, here versus there. So let's zip back to 1979. There are probably only one or two of you in the audience old enough to remember this. Okay. Excellent.
80 years old.
Well, thank you for remembering, and a few more of us do as well, I'm sure. This is my own personal 1978 or 79 Apple II Plus. It was kind of an amazing moment in the history of computation. This is when all sorts of people got access to computers and could make them do things. This still exists today. It still works today. It still boots up in under a second today and does what it did back then as well now as it did then. And it's hard to say that about the longevity of modern day technology. Now, when you use this machine, your stuff is here. It's literally under your fingertips, right? There's no network, so whatever the machine is doing, it's doing it right there. And you feel that. Because, one of the characteristics of this machine, and whether it was this one or the TRS-80 or the Atari or even the Sinclair ZX-80, it doesn't matter. What happened when you turned any of those machines on is that you would get a little blinking prompt, a little blinking cursor, and the cursor was a programming language. So although these machines didn't and couldn't do much, the thing that they said to you, the message that they gave you when you turned them on was, make something. Right? It's like the empty page in a pen. Unless you make something, nothing happens. And people did. People rose to the challenge in astonishing ways. Folks like Dan Gorlin wrote, kind of invented modern video games. He wrote Choplifter in his garage. Herbie Hancock very famously invented a whole swath of modern kind of computer-driven music on exactly one of these devices. And that was a huge deal. This thing had very little capacity, but people made it do amazing things. And Dan Bricklin and Frankston, sitting in a garage somewhere in Cambridge, Massachusetts, wrote VisiCalc, the world's first electronic spreadsheet. And they weren't just upgrading an idea, they made a category by creating that program. And the program itself turned out to be so valuable that it increased sales of this chunk of plastic by something like a factor of 10. Which is an interesting thing to think about, so where the value lies. But the point was, people made stuff. If we now zot forward 30 years, this is 2/3 of a particular company's ecosystem, oddly enough, the same company's ecosystem, of modern devices. They're still computers, although, as I said, we don't call them that. And when you unbox these devices, as we say, and turn them on for the first time, it's just spectacular. I mean, they in some cases sing to you, they show you incredible movies, but what these things don't have is a programming language. So the invitation is very, very different. The philosophical meaning of these objects is very, very different from what that same company was saying 30 years before. And when you use this stuff, what's most salient about them is that they're connected to a network. And all your stuff isn't actually on the thing. It's somewhere far, far away. It's in the cloud, presumably getting damp or something. Who knows what happens up in the cloud? So your stuff has suddenly floated away. And I don't mean to deride the idea of networked computation and stuff like the cloud. It's fantastically valuable, and we wouldn't change it for a moment. But something's been lost. The here-ness of the experience has a little bit been lost. And so one of the things I'd like to do tonight is to see if we couldn't pull back some of the experience, pull back some of the here-ness, while not obviously giving up any of what's great about the network. Now, we can't talk about the history of modern computers and modern technology without referencing this, the same company yet again. This was a momentous occasion, 1984. This was the moment when the machine learned to talk in pictures. Instead of text, instead of a one-dimensional command line where you would type some stuff and the computer would type stuff back to you, which accesses a particularly kind of verbal and logical and abstract part of the human brain, this thing is accessing the human visual system, a very, very different part of your neocortex and all your wetware up there. And all of a sudden, this made it so that lots of people could easily get into the machine, could make sense of it, and find value in it. So this is the world's first giant, wholesale, full planet, full population step forward in the user interface, the graphical user interface. And what's weird is that we haven't changed since then. This is still what you have on your laptop computer. More pixels, their color, there's a network plugged in, there's all sorts of stuff that's a little bit faster, or a lot faster, and a lot better, and a lot higher res. But it's these same ideas. It's overlapping windows and multiple applications and all that stuff. So that's a really interesting circumstance. That means that either we can't do better than this, or that no one's tried. And I think that it's the no one's really tried, and I think therein lies a great deal of danger, because we're now more than one human generation past this, and we're, in a sense, almost in danger of losing our institutional human concept that maybe there's progress possible. Nonetheless, it is to this system's huge credit that it still works today, that it's still good enough, and so we doff our hats to it for that. I'm going to, it seems to me that there's a great opportunity here. We've gone from desktops to laptops, and today most people's interaction with computation comes in this form, or in the form of a tablet. And that's not really a step forward in UI sophistication. What we're after, I'm going to claim here that what we should be after, at least part of what we should be after, is a UI that's more capable, a UI that is like a big exoskeleton, a human exoskeleton for making us be understood by the machine, for transducing our will into the machine's world, and therefore, getting more out of the machine. So this is sort of a step to the side. Its great feature is portability. But if you think about it, you wouldn't write a novel on this. You wouldn't type more than 140 characters on this, right? You wouldn't plan a surgery on a tablet, and you wouldn't perform finite element analysis on a bridge that you're designing on a tablet or a phone. You would use a, long pants, big girl, big boy computer. We don't use that word much anymore, computer. We don't seem to like it, and maybe we're right not to like it. So what could it be that next UI is? Because the next big step in computation is not going to be more cloud or more Hadoop or, we already know that story, and it can only incrementally get more impressive, I suppose, but that can only be a quantitative change, not a qualitative one. So what we're after is a qualitative change. And this is the first big kind of hint or suggestion or assertion, I don't know which, about the ideas that you'll see here today. If you think back to what the Macintosh development team was after when they invented this new GUI, well, you can look at what the icons represent. You've got little pictures of trash cans and files and documents and sometimes even file cabinets on your desktop. And the problem that they were solving was file management, moving stuff from here to there, sorry, which was a hard problem to solve, and we're grateful that they did. But that was about as much as that they, as they could get their arms around in a design sense and in a technological sense. And again, it served us well for 30 years. But from a weird perspective, that means that the machines we have today have this kind of clerical soul. They've got kind of a Kafka soul. And what does that do? Well, it's not insignificant. It seeps into the experiences that we build on top of those operating systems, on top of those UIs. And I don't mean to be too strident or dramatic about it, but that sense pervades everything that we do in a very kind of 60 hertz, low, subliminal way. And I think that if, the Kafka soul, if the clerical soul is what we've got today, we can ask, what should it be instead? And part of the message here is that I believe that if you convince the machine, if you design the UI, and therefore the whole machine. What do you mean by UI? UI means user interface. So it's what you do with the mouse to, drag around little pieces of, drop-down menus and scroll bars and all the stuff you got to do to communicate with the machine. I apologize. I'm sorry. No, not at all. I failed to define terms, which is always job one, so I'm letting you down already. I apologize. Won't happen again. See? There we are. It's only a matter of time. If we could convince the machine that its job, its purpose on Earth was in the field of design, that if it literally existed to be an assistant to human beings pursuing design sorts of activities, then we would end up with radically more powerful, more capable user interfaces that would still be capable of performing, acts of file management and could still run your spreadsheet, but would talk to us and allow us to talk to them in a way that's much more ultimately human. And so that's what we're going to be after for the next few minutes. Now, as Chris suggested, a part of the way I see the world comes from about 16 years at the MIT Media Lab. We're not going to talk much about that today, but the salient part there, I think, is that the Media Lab was conducting a very odd academic experiment at the time, which is that it was trying to collide disciplines. It was a place, and people have tried the kind of interdisciplinary, multidisciplinary thing for many years, but it was really forced on us in a brilliant and wonderful way at the Media Lab. So you were literally cheek by jowl or working directly with people in radically different disciplines. So, we had hardcore computer scientists working with the founders of the cinema verite documentary film movement. We had laser physicists and holographers working with computer graphics people and architects. And all of those collisions, just like at CERN, would throw off new particles. You smash some heavy stuff together and you get little swirly, squiggly things. And those new particles were, in some cases, new disciplines, in other cases, new companies, and in third cases, new ideas. So that was what was really important about the Media Lab back in the day. But you're all academics here, so I don't need to describe much more about the kinds of effects that being in an academy can have on you. The other half of the set of influences that are kind of rummaging around in my skull have to do with a very unusual circumstance, which is that I kind of through the usual series of clerical errors, ended up migrating directly from an academic environment into the art department of the film Minority Report, the 2002 film Minority Report. And another mutual friend, Alex McDowell, for my money, the world's greatest production designer, still living anyway, took very seriously the brief from Spielberg that in order to create, quite simply, Spielberg wanted a believable 2054. It says 2080 here, but we got downgraded. Future Washington, D.C., 2054. Everything had to be real because Spielberg was convinced that, he insisted that he was making a noir. Minority Report was going to be his noir film, his homage to film noir, and it was only incidentally set in the future. So to the extent that it was possible to have a world that looked seamless and real and it just naturally and organically extrapolated from the world that we have and know today, his thought was that audiences would be able to ignore the flying cars and other stuff and get on with the noir business. And Alex took that charge extremely seriously, and he kind of, at that moment, in addition to creating the world's first digital art department, set into motion a practice that he today, and others as well, called world building. So because Alex was hired on the same day as the screenwriter for this film, we didn't know where the film was going to go. Right? We couldn't say, well, we're going to be in a subway but not a hospital. Which meant that we had to design a full world. We had to design a full Washington, D.C. 2054, both the hospital and, and the law offices and the subway. And what do communications devices look like? And what is architecture changing into? And what's transportation? And how do you cook? And every other question that might get asked, because a scene might get written where we need to see someone, preparing hummus in a kitchen. And you better know how you make hummus in 2054, because you don't want to be standing there as Spielberg screaming behind the camera. So we came at this problem as this fantastic collision of urban planning and architectural practices, but also anthropological research, political extrapolations, and of course lots and lots of technology. All of that research and all of that synthesis was collected together into what became known as the Minority Report Bible. This was also a brand new practice in film preparation. And this is a vast distillation of a much larger set of ideas that we had. But we had to be able to say specifically what was going on with ecology. Do we still have internal combustion engines? No, in this case, actually, we've solved a big part of the ecological set of issues in the world. We're saying that it's that Big Brother is there, but not to form a police state, but because it's a highly consumerist society, and you're tracked all over the place, so you can be pinpointed and advertised to. Sounds a little bit familiar all of a sudden. Indeed, cooking and culinary arts, can you build new kinds of surfaces that can become alternately hot and cold so you can cook and do sous vide stuff all on the same surface? Personal information devices also, I think you see the pattern here. We were supposed to be predicting 50 years in the future. We barely made it 10. A lot of this stuff looks kind of familiar at this point. New kinds of transportation, maglev vehicles, and actual technology. This is not an actual technology. Here's the flying Pez dispenser cop cars. And this is absolutely not an implementable technology. These are psychic teenagers, which form the backbone of the story, so there was nothing really we could do about explaining it. We just had to say, yeah, that exists. Now, one of the interesting things is that when you build that much world, when you design that much world, most of it doesn't end up in the film. Most of it doesn't even fit in the film, and it's not because it's not a good idea. It's just because a film is a really small container, it turns out. So there's all sorts of great things that didn't make it into the film. This is one of several of my favorites. These are paparazzi bots that would fly around to areas of interest, crime scenes, sporting events, and do, physically jostle with each other and probably get, punched by Alec Baldwin or something as they try to get visual access to scenes. We were first downgraded to 2044, which was all well and good, because that would have actually been a good amount of time to try to extrapolate forward. And then someone, I still hadn't been able to get an answer, upgraded us to 2054 a couple of weeks before the film came out. So if you watch really carefully, you can see that in the scenes where people are discussing time, new dates have been kind of shoved into their mouths, into the dialogue to make the calendar math work out. And this was the single biggest piece of technology design that the film required. This was the inner sanctum of the pre-crime area. If you've seen the film, this is where all of the data that came, all of the imagistic data that came out of the precogs, the psychic teens, would land. So tens or hundreds of thousands of little images or video clips, essentially, from their dreaming brains would be extracted and would show up here. Because the precogs dream like you and I, you can't tell them what or where to dream. It's all kind of fragmented and so forth. So essentially, the job of these pre-forensic cops was to sift through all this stuff and make sense of it, to put together enough geographical and visual clues so you could figure out where and when the crime was going to happen and to whom and by whom, and get there in time and stop it. And Spielberg, as Chris suggested, very presciently said, I don't want to see any keyboards, I don't want to see any mice. This is 2054 or 2080 or 2044 or whatever he said at the time. That seemed great to me, because shouldn't we have gotten rid of the mouse, by about 1994? 10 years of run after the Macintosh seems like a great thing, but we're still using it today or its derivatives. Yeah, you and me both. So we went at it, and this was partly from not knowing any better, but we went at this design problem exactly as we would have gone about a real-world user interface design problem or industrial design problem or computational design problem. What if you actually had to build this stuff? And that meant a great deal of research into all of the human gestural communication systems. Humans have invented a lot of them over the years. There's everything from, American and International Sign Language, sort of ground air traffic control signaling. There's SWAT and police gestural systems. And of course, interestingly enough, there are even gestural music systems, which ironically Spielberg had used 30 years before in Close Encounters. So Spielberg loved the idea that his characters could stand in this really grand cinematic way in the middle of a vast array of visual information and literally conduct it using their hands, as if they were Mickey Mouse on the promontory in Fantasia or an orchestra conductor or something like that. And so, we synthesized a new kind of human gestural language that was specialized for this kind of forensic task of sifting through images. We went ahead and made training videos because at the time, computer graphics modeling and rendering and compositing programs were just becoming widely available and inexpensive enough that you could do this. And this was an important step, too. So this is, in a sense, this is almost live prototyping. And it was actually this document, as cheesy as it looks, and that's not the point, this was the document that convinced the producers and the actors and the directors that they would not have to be embarrassed by those scenes. They wouldn't have to cut away from those scenes. That, in fact, these scenes that use a new kind of UI technology could propel the narrative forward, could be used to help tell the story. And it's not the first, nor is it the last film in which people tried to depict a gesturally driven computer system. And in every other case, and we've seen a few of those cases, in fact, what happens is the director says, we got to shoot the gestural scene, have Ben Affleck wave his arms around, and we'll figure it out later, right? And what happens when you do that is that the poor editor gets a bunch of footage dropped on her desk, and it doesn't make any sense later, because it can't, because it wasn't planned and it isn't real. On the other hand, if you train the actors, which we did for days and weeks, if they have access to documents like this, then those actors can end up actually using this system, even though it's fictional, even though they're not going to see anything on the big curved screen. They can imagine, they're actors. And what comes out the other end, once ILM is finished compositing in the data into those screens, is a new sense of causality, a new sense of reality. And I'll skip the rest of that. So it came time to shoot. We did shoot. People were so excited by the early results that Spielberg commissioned additional scenes to be written so that more characters, the Neil McDonough character and the Colin Farrell character, also got to use this new technology. So it took on a life of its own in the film. And what came out was somehow resonated with people to the extent that journalists still feel compelled somehow to write about this film and these scenes today when they talk about the future of technology. And I think there's a few things going on. One, it looks cool, and that's what people write about. But I think it's not just that. I think that we as humans are process junkies. I think we like to see people doing complex things, and we like to see it happen in a way that's legible to us. And I think audiences watched these scenes and felt like they could kind of follow it. They could kind of imagine using a system like this themselves, and they could kind of get a sense of how it worked. And so they're seeing a team come together and solve a very difficult problem, a time-critical problem, because someone's going to get murdered in real time. And I think that's what's ultimately germane, most germane about these scenes. So these, in a sense, this is a depiction of a new kind of more human-centered UI being used to solve a problem. More than it is a scene that shows people waving their arms around or using some kind of newfangled technology. And in retrospect, we realized that unwittingly we sort of had hijacked the Hollywood filmmaking process to prototype something that could become real. We'd inadvertently conducted what I suspect is the world's largest user focus group test. We'd put this new hypothetical system or product or whatever you want to call it in front of, I don't know, 50 million pairs of human eyes, 100, I don't know how many people saw the film, but a lot. And so it was really interesting to watch audiences watch those scenes and kind of understand what they thought about it and talk to them afterwards. And it didn't take long before we felt like there really was something here. So let's build this stuff a third time. We built it once in academia as a set of working prototypes, real code, real working programs, but prototypes. We built it a second time in a fictional setting for a film, and in doing so had undertaken a process of refinement and simplification that I think actually is perfect. If you were trying to make a product, you should do exactly that same thing. And if you're really fortunate, maybe you can get Spielberg to make a film about it, because that's a great calling card. Now we were going to build it a third time. We're going to build it in a commercial context and in such a way that it could start to be applied to real-world problems. And so that's the proposition now. Does something like this really help us? What does it do? I'm going to go quickly through this, but there was another much less commented upon aspect of the film, which was that we were saying that that display technologies were going to go haywire. They were going to explode. There'd be display and pixels everywhere in every possible domain and on all sorts of surfaces and at all sorts of scales. And this turned out also to be a pretty accurate prognostication. We're getting there today. And there's something interesting that happens if you say, we're going to have displays everywhere. What should that world be like? There's a series of almost logical deduction steps that you can take that helps you conclude that we need really, really different kinds of computation and different kinds of UI, because it's a weird artifact of the way that we've built and consumed devices and computers up until now. It's an artificial one, but it's real because no one's done anything different. And that is namely that all of your stuff, all of your data, your computation, your communications stops at the physical boundary of this device or that screen or whatever it is. It's sort of one device, one chunk of pixels, one task, one idea about who is using that stuff. The question is, what would happen if we broke open the edge, the boundary here, the physical boundary, and let computation and UI and communication spill from one set of pixels to the next? And that's a big part of what we're going to talk about. So we started a company called Oblong to try to bring these ideas, not so much even the technologies, but the ideas into a form where lots and lots of people could use them in kind of professional contexts at first, and eventually, hopefully even in universal contexts at home and for personal uses as well. So I want to go very quickly through 5 principles that underlie everything that we do when we think about building this kind of technology and designing these kinds of user interfaces. 1, space is a critically important piece of our lives as corporeal beings, as human beings. Space is kind of where it all goes down, right? If you have it, it's in space. If you do it, it's in space. And there's giant chunks of your human brain that are evolved and dedicated to understanding your position in the world, your position within interior architecture or out in an environment with a horizon, your position with respect to other human beings that you may need to interact with, and so forth. None of that gets exploited or accessed when we use technology the way it's construed today. But it seems like such an important idea. If you're a programmer and you use computer programming languages, you'll note that as fundamental as space is, no programming language lets you talk about it. No programming language really lets you talk about geometry, the simplest idea there is. So we said, yeah, it's all about space. And what happens when you make that assertion and you build a new programming language that has as its core tenet that stuff is in space, that pixels actually are in space, then this starts to happen. Pointing becomes very, very easy, but also incredibly powerful. Pointing is a unique human gesture. It's the geometry gesture. It's the one that connects your body to distant space. And it means that anything you can point at, you can grab and manipulate. The way your body is set up, the inertia, the biological mass, And form means that navigation is very important. Touch is a subset of the kind of free space interactions that we can provide with a system like GSpeak. And it's just really profound in a way to be able to reach out and grab an object like that, whether it's literal in that case or abstract, and pull it toward you. Here, an interesting thing happened, which is that the window of pixels moved underneath objects that were in physical space. And here's a physical pixel, and it should submit to the same kind of spatial gestural control that drives the rest of the world. Navigation is such an important idea. There's about 25 years now of noble and really successful experiments in visualization, computer-based visualization, but it's kind of only half the problem. It's the output problem. And when you're looking at a visualization, it's kind of a megaphone, right? But if you could suddenly allow people to fly through it, then that's lighting up both hemispheres, as it were. It's accessing big parts of your brain that don't normally get the chance to talk together. And new kinds of understanding come out of that. I think we're seeing this again. But you can quickly teach your two hands to do two different things at the same time, like as a violinist understands. So you can make marks with one hand, spin the space with the other hand, and you end up with kind of a digital potter's wheel. And sometimes you don't have to wear gloves even. So the idea that you can get through any kind of data, that you can reach in and kind of pick up pieces of the world that you want to understand, and understand them visually the way you would in the physical world, either by moving them around in front of you or moving your body around them. That's kind of a profound thing, I think. And here you see a hint about what's going to come in a few slides, which is that stuff can spill across any number of screens. And more than one person can use a system like this at the same time as well. So that goes on for a little longer, but let's jump ahead. Second, you should always apply, I think, the following litmus test to new technology that you build, especially new user interface technology, which is that I think if you get it right, if you can build it the right way, then it should be imbued with a sense of exhilaration that comes out directly out of the aesthetic experience, but it's a visceral aesthetic experience. If you can build the UI the right way, then using a computer to do what you want it to do should feel like skydiving or skiing or playing the oboe or performing a tricky surgery or whatever of the countless hundreds of thousands of things that we do as human beings with our bodies, where our bodies are understanding the world. And we're kind of in complete touch with cognitive touch, but physical, literal touch with the stuff that we're doing. We can build interfaces that work like that, and you know when you get it right, because you can feel it with your body. So this is the system that Chris alluded to earlier. This is the University Art Museum at Cal State Long Beach, and we put together this, which was a set of interfaces that let you access film. There were about 18 films that we imported into Tamper at the time. You could zoom through the film in time, but then you could take it apart in space. You could pull any character or prop or a bit of scenery out of the main screen and pull it down to this kind of composing table here. And then you could go next door to another movie that was made at a different time and probably in a different country, and immediately conduct a kind of cinematic heresy by putting together bits of stuff that were never intended to live together in the first place. But that's really interesting. New stuff comes out of that bricolage process. And as much as this is maybe a glimpse at the future of some kinds of media manipulation, for me, at the end of the day, it turned out to be a metaphor for how powerful, power not in the sense of raw, brute power, but power in the sense of sophisticated control, how much power you ought to have over your own stuff. The stuff in your digital world, which is yours, should be susceptible to this kind of taking apart and putting back together, just as you could with any other element, and at such a fine-grained level. And something else that's happening here that I think bears just a moment of thought is cinema itself. So cinema is a unique human language. It's about 120 years old. And its unique property is that it's incredibly good at depicting space and time and causality and narrative arcs and human emotions and the evolution of those over time. And for those 120 years, cinema's been an output-only medium. But by the time any of us is 8 years old, we've absorbed all 120 years of that language. So we're all practitioners of it. I think there's something really, really amazing possible if we started to say, what would happen if we use cinema as an I/O mechanism? What if you could speak cinema as well as consume cinema? That ought to be a really, really powerful way for us to speak between ourselves and the machine. I won't spend much time on this one at all, but it is really, really important for any of you who have programmed. You know that programming languages are like a wasteland. It's like a tiny little scrap of the Merriam-Webster dictionary torn out. There's about 12 words in total used by every programming language over and over and over again until they're so overused that they have little meaning left or possible because we've just put so much meaning on them and they're supposed to mean all these different things. We have, after all, however, the totality of human language, whether it's English or Finnish or anything else, available to us, and there is not any reason that that kind of low-level task of programming, which is to say creating with the machine in its own kind of native language, couldn't also be literate, couldn't be more elusive than it is today. And so when you work with GSpeak, when you work with Oblong systems, the vocabulary encourages you to think deeply about what you're doing. I sort of feel like, you know, it shouldn't just be the result, the product that has an aesthetic quality. That should be supported by and reflected in what you do to get there all the way down. It's certainly that way in most other human disciplines. Why it can't be in the world of programming is a strange thing, but we can do something about it. So just very, very briefly, when you work with Oblong systems, most of the metaphors are biological, which I think is an interesting place to start. The systems that you build in these programs respire. They go through a rhythmic, periodic process of inhaling, travailing, and exhaling, and I don't expect anyone to care about the particulars of the code, but the vocabulary is worth thinking about. This isn't the only thing possible, obviously, back to the original point, but if this is possible, then other metaphors, other systems of language are possible, and that's how you work with computers at the low level in a kind of language. It should hew to human language ideas and principles. So the respiration gets to the next point, point number 4, which is to do with time. You can set up structures that are about time. Just like computers have not traditionally known anything about space, they also have known nothing about time. So that's it. The 4 dimensions that circumscribe everything in your life and my life are completely alien to machines. We're trying hard to change that. The atmospheres and the whiffs are breathed in and out during respiration. It gives you an opportunity to ask the program about itself. Something also that most modern languages don't do well. You can't ask them to introspect. Geometry, as I said, is a core piece of the world that we're building. We want it to be the most basic construct that the machine knows how to talk about. So when you talk about screens, you don't talk about this point as being 0, 0, which it is in most programming languages. That's 2 integers that only talk about where this pixel is with respect to the other ones on this screen. In GSpeak, every pixel has a 3-space location. So if there's more than one screen, the pixels on that screen have a unique name, a unique address. And it's the same addressing scheme that we use in walking around the world and dealing with it, which is what makes things like pointing so easy to do. And programs communicate together in loose federations using a system that we built called Plasma, which is basically like a rewindable internet. But unlike the last 50 years of computer science, whose metaphors tend to be based on the telegraph, point-to-point communication, the idea here is, again, biological, that many programs, many objects connect together by kind of dunking a proboscis into a thing we call a pool and depositing little messages or big messages in that pool, all of them at the same time. The messages are called proteins. And the only property that exists from the pool's point of view is that it's strictly ordered. We're not going to say whether application A or B gets to go first with the protein. We don't know, but once the proteins are in the pool, then they're in a fixed order. And everybody gets those same proteins back out in the same order. And what this means is, and it's rewindable. So you can rewind this whole thing, which means you could have a brand new program, like you boot up this phone for the first time, and it joins some federation of interacting processes because we want stuff here to be able to talk to stuff there. It can join up with a pool and rewind time and go back and figure out enough context, figure out what's gone on in order for it to kind of catch up and become one with the present. And when you deal with proteins, it's said that you metabolize them. So again, a set of biological metaphors is very interesting to think about. The way biological systems, human systems, other mammalian systems work is maybe a good place to start. And now to that point of time. So we want to teach the machine that outside world time, clock time, human perceptual time is really, really important. And one of the key reasons you want to do that is because, again, you might have stuff on more than one screen. So here's a little piece of media running around 5 different screens. It's dark, I know. Being driven by 3 different computers, running 2 operating systems, but with GSpeak on top of all of it. And what you get is what you would expect as a human, but what you would not expect as a computer. In other words, the experience and the interface are all conformed in time and space. So this is GSpeak doing a lot of hard work so that you, as a user of that system, or even as a programmer, don't have to think at all. You get what should always have been the case. You get all the machines and all the pixels working together in your world. The screens exist in your world. You don't exist in them. Here's a very similar example in which we're taking a little tiny model of a tree from a Macintosh and sticking it on a giant screen that's driven by a Linux system, and then bringing one back, and then switching input devices from a Kinect up top to a leap motion sensor down below. So we're getting toward the last point, which is an idea of plurality, that it's not just one input device. It's not just the mouse or something else. It's actually everything all at once. It's the right tool at the right moment. And this is incredibly hot off the press. This is only about 72 hours old, but I thought I'd show it. This is a bunch of financial data, and it hasn't been labeled yet, so it's still just very abstract, but also very literal in a way that's completely appealing. And the idea that you can reach out using one of Oblong's spatial wands there and just pull yourself through all of this data suggests that maybe new kinds of understanding are possible. If you can do that with all the world's data, maybe you have a chance of being able to really understand it. So finally, the last principle is one of plurality, and plurality of everything. It is the second and other unfortunate legacy of these devices and all such devices. And it is, again, an artificial evil legacy that they all assume that there's only one person out there, you. Right? It's a half, well, I guess it's a solipsistic worldview. I'm not sure what it is. But you use one of these things, and it's staring out at you, and you're staring in at it, and it doesn't care about anyone else. And yes, I could look over your shoulder as you use your laptop, but in no meaningful sense am I using your laptop. So the question is, what would it mean if we exploded that or inverted it and made it so that the basic assumption was that more than one person could use a machine at the same time? And I want to come at that conceptually 2 ways really, really quickly. One is, it's just sort of an analogy thing. So we talked at the very beginning about the command line interface, where you type some stuff, some arcane stuff, and other stuff comes back to you in textual form. And we did something. We, as designers and technologists, we did a thing that I'm just going to name hoist. We turned the command line interface into the graphical user interface. And something really interesting happened. When you used one of those old machines, it was kind of single task at a time. So maybe you were inside VisiCalc using the world's first electronic spreadsheet, doing a bunch of stuff. But if you wanted to edit a textual document, you had to literally shut down the first program and boot up the word processor. And if you wanted to send email, which you couldn't have because there weren't networks at the time really, you would have had to shut down the word processor and start up the email program. When we went to the GUI, not only did we get the machine to talk and think in pictures and converse with us in pictures, all of a sudden there was this new thing happening where all that stuff existed at the same time. And we're good for it. Cognitively, we can clearly handle that. That's not the issue. It was a design issue. It was a UI issue. So now you could work in the spreadsheet and copy a bunch of cells out of that, dump them into a text document in your word processor right in the middle of it, a separate program that was also running at the same time, and then take that whole file and dump it into email and send it off. That's a qualitative difference in the machine's capability and the set of capabilities that it affords you. So the big question is, what would it look like if we did that same hoist thing to the GUI? What would we get? And it would be this kind of radically parallel thing. And I'll show you in a second one view of what that might be. The other thing that I wanted to suggest to appeal once more, one final time, to architectural analogies is that, this thing is like single occupancy architecture, right? It's like saying, well, we built this magnificent campus, But if Chris is in this building, no one else can be, right? Even though there's room for it. Or single task architecture. If we're using the fax machine, then the coffee maker doesn't work. You can only do one thing at the same time. We want to go in the opposite direction. We want systems that allow more than one person to use them at the same time, more than one task to go on at the same time, and lots of devices to serve as portals, as entryways, as control surfaces into those. So this is the last little bit here. This is a system that Oblong makes for general purpose collaboration. And again, in some ways it's a metaphor, but it is, I think, the first instance of that kind of massively parallel workspace that I'm talking about. So we've got a huge wealth of pixels, pixels on the front wall and on the side wall, and the point is that everyone can use them at the same time. And you can use them from whatever device you brought into the room with you. So if you live and die by the tablet, that's great. You see a woman here using the tablet to control the big shared workspace. You see her here uploading some content into the big shared workspace. Now she's actually switched modalities. She's picked up the spatial pointing wand, and she's just using it to point, the most natural thing in the world, to manipulate that image so that they can discuss it further. This woman has a smartphone that has a camera in it, and the system's contract with you is that it will respect any of the capabilities of any of the devices you bring with you into the room. So this is a new way to inject information into the dialogue, into this visual dialogue, just by uploading the image. And you wrap all that around teleconferencing, and that becomes yet another important human channel. But critically, it's fluid, it's resizable. So if you want to see the pores on the other person's nose, you can make it really, really big. But when it's time to get back to work, you probably shrink that window down. Now this guy has plugged in his laptop. Maybe he's the only one in the room who's got that CAD modeling program. But by plugging it into the system, by plugging it into the room, he's making it available visually, but also in a manipulatory sense to everyone else in the room. Here's a perfectly great bit of meeting room kit, the whiteboard. It doesn't need to become digital implicitly. It just needs a camera looking at it so that it can become a first-class citizen of the workspace. So what you see here is essentially an environment for creation, an environment for synthesis, an environment for discussion and decision-making, whose metaphor, whose way of being is architectural. This is, I hope, this is a kind of architectural computer. Because any one of us, any two of us, I should say, could come into a room and collaborate as long as there's no computers involved. We could pass a piece of paper back and forth across the table and scribble on it. We'd stand side by side at a whiteboard and scribble together. We could do any number of things. We could sculpt together. We could use our hands together. It's just when the computer gets involved that that gets broken apart, and it's one person at a time, one thing at a time, one idea at a time. If you make the machine architectural and behave in all those same ways, I think you've really got something new. Now, all of the inbuilt instincts and understandings you have that would allow you to step up to one wall and pull off something that's tacked to it and move it over to another wall is equally valid here. And your work process can proceed in exactly the same way. So here you see multiple rooms that are like this being connected to each other. And we've gone from multiple people collaborating in one room to people collaborating across multiple spaces and so forth. So that's one tiny look at what technology ought, I think, to be affording us. You know, workspaces that are democratic, that are parallel instead of serial, that are nonlinear instead of linear, that are fundamentally spatial and architectural the way they ought to be. And these are the kinds of systems that we ought to be building together, designers and technologists and everyone in the world who's interested in it. Systems that are about enhancing and holding in human attention and helping humans keep their attention rather than being devices of distraction, which is what we tend to build for ourselves today. Machines that, as I said at the beginning, are kind of amplifiers of human intent, transducers of human will, little extenders for what humans can do in the synthetic domain. Machines that capture and, again, amplify meaning rather than randomness or mere entertainment, and that are environments, of course, for human synthesis, for that basic human drive to make stuff, to create. And the word that keeps appearing here, of course, is human, because that's what the systems should do and believe that they're here on Earth for, is to help us as humans and in a human modality, not the other way around. So that's about all I bet you can take for now. Thanks.